Let's look at final exam question number 64. If you have the printed edition, it's on page 335 of Electricity Demystified, second edition. Question number 64 in the final exam for Electricity Demystified, second edition. If we increase the frequency of an electromagnetic signal by a factor of 100, what happens to the free space wavelength? So EM stands for electromagnetic. In free space, electromagnetic fields or signals propagate like waves. Lambda, lowercase Greek letter lambda, represents the wavelength, the distance in space in a straight line from a point on the wave to the same point on the next cycle or the next iteration of that wave. We have the frequency and we have the wavelength. If we increase the frequency, we decrease the wavelength. And in fact, if you will go back to page 260, page 260 of the printed book, it appears in chapter 11, just underneath the header frequency and wavelength. You go a while, and then near the end of that section you come across two formulas. Lambda equals C over F, and F equals C over lambda. What is C? Well, the wavelength in meters equals the speed of light in meters per second divided by the frequency in hertz. Conversely, the frequency in hertz equals the speed of light in meters per second divided by the wavelength in meters. We don't need to have any specific numbers, though, in order to answer this question. We're only dealing with relative quantities. C is a constant, equal to about 300 million, or 3.00 times 10 to the 8th power, meters per second in free space. So that is a constant. So if we double the frequency, we cut the wavelength in half. If we make the frequency 100 times as great, we make the wavelength 1/100th. 1/100th is great. That is choice B. The wavelength becomes 100 times shorter. As a common example, if you have a wave of 1 megahertz, well, let's say 1.00 megahertz. In free space, you're going to find that that is a wavelength of 300 meters. You can do the calculations remembering that mega means a million. 1 million hertz, 300 meters. If we were to increase this frequency to 100 megahertz, we would end up with a wavelength of 3.00 meters. 100 times as great, 100 times smaller. So frequency is proportional to the inverse of the wavelength, and conversely, wavelength is proportional to the inverse of the frequency. That's always assuming that we stick with the same medium like free space, so that the speed of the wave propagation remains constant. Again, in this case, the answer to the question is B.